Welcome to solverfy.
So this is the force diagram for the semi-cylinder. So now let's apply the force equilibrium for this case. So we have net force along xy direction is equal to 0. So we have P sine theta minus F is equal to 0. So we have P sine theta minus mu Sn is equal to 0. Since we assume that the semi-cylinder is in equilibrium, therefore the friction can be equal to the static friction, which is mu Sn. And then on y direction, we have N minus W minus P cosine theta is equal to 0. So now let's try to cancel out the N here. So that's how I do it. So it's just simply use equation 1 plus mu s times equation 2. And this will give us P sine theta minus mu SW minus mu SP cosine theta is equal to 0. So we have a P is equal to mu SW over sine theta minus mu S cosine theta. So now let's take a look at the moments about point B. I'm sorry, not point B, point A. Consider counterclockwise moment is positive, clockwise moment is negative, and this will give us such equation here. So if we do some arrangement here, eventually we'll have force P is equal to W times 4 sine theta over 3 pi times 1 minus sine theta. So remember, P can be also expressed as mu SW over sine theta minus mu S cosine theta. So now let's keep continue. So now we can set out these two equations equal to each other, since both of them are equal to P. And this will give us mu SW over sine theta minus mu S cosine theta is equal to W times 4 sine theta over 3 pi times 1 minus sine theta. So as you can tell, W here can be cancelled out. And this will give us mu S over sine theta minus mu S cosine theta is equal to 4 sine theta over 3 pi times 1 minus sine theta. So now let's plug in the values for 0.3, which is the value for the coefficient of static friction. And this will give us 0.3 over sine theta minus 0.3 cosine theta is equal to 4 sine theta over 3 pi times 1 minus sine theta. So now we can use a calculator to calculate the angle. Eventually, the angle theta is about 39.5 degree. So now let's determine the corresponding force P, which is equal to mu SW over sine theta minus mu S cosine theta. So we know W is the gravity, which can be equal to mass times the acceleration of the gravity. So the mass of the semi-cylinder is given as 20 kilograms. Therefore, we have force P is equal to 0.3 times 20 kilograms times 9.8 meter per second square over sine 39.5 degree minus 0.3 times cosine 39.5 degree. And this will give us the corresponding force P is equal to 145 Newton. And these are the answers for this question.